Now we are still on radii of inscribed and circumscribed circles. This is part 2. So we are yet to watch the first part or part 1 of this topic. Please do so. So we want to look at part 2. This time we want to look at if you are given a right angle triangle in which one of the angles is 90 degrees. How do we determine the radius of the inscribed circle, and also how will you determine the radius of the circumscribed circle when we are given a right angle triangle? This is inscribed circle, and here we have the circumscribed circle. Now here we have a theorem of tangent. So from here to here, so this side, consider this to be, this is a square. What we have 90, this is radius, opposite sides are equal. This is said to be radius. This is radius, then the other side here is said to be radius too. So this is a square because all the sides are equal now. So and the angles are also equal. Now in this case, from here, that is point A to point C, we have B. So when you take away R from B, you are going to have from A to this point here. So therefore, from A to this point, we have B minus R. So the length of tangent, so from A, when the tangent meet at a point, the length of the tangent are equal in any given circle. This is a tangent, this is another tangent, they meet at A. So therefore, let's label this to be D, and let this to be E, and this will be F. So AD and AE are equal. Therefore, this will be B minus R. So from here to here, that is CF is said to be R, and CB or BC is said to be A. You want to tell me FB or BF, you are going to take away R from A. You have A minus R. So the same thing applies. FB equals to BE. So this is said to be A minus R. Now the length of AB is C, and it can also be determined by adding B minus R, that is AE. So that is AB equals to AE plus EB. That is the length of AB equals to AE plus EB. AB is said to be C, then AE, B minus R, AE. That is B minus R, then EB or BE is said to be A minus R. So we have C equals to B plus A. Adding this together, the minus R will be minus 2R. Let's take minus 2R to this side and C to the other side. So we have 2R equals to B plus A, then minus C. Divide both sides by 2. So it implies that R equals to B plus A minus C divided by 2. Or R equals to, you can arrange alphabetically, A plus B minus C, then divided by 2. When we are given the length of the sides, to check whether the triangle is said to be right angle, so you can simply check by taking the square of the longest side and check the sum of the square of other two sides. That is, if the square of the longest side is equal to the sum of the square of other two sides, then the triangle is said to be right angle triangle. If this equality obeys, then that you are expected to apply this formula to determine the radius of the inscribed circle. Thank you. Please like, comment, and share. So watch out for the second part, which is circumscribed circle.